Hello, and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. We've got Robert Brehm, who is the co-founder and CTO of a fascinating company called FLEXeCHARGE, to talk about what he does and the company. So thanks for joining us, Robert. It's great to have you with me.
Yes, thanks for the invitation.
So if we could get started by finding out a little bit more about you and your background and how you came to be doing what you're doing now, that would be great.
Yes, so I'm an engineer, and actually I'm an engineer by heart. I love engineering. I studied mechatronics originally. I've done my thesis in Canada for a company doing oceanographic research or building equipment for oceanographic research. And after a while, I thought it would be nice to learn more about engineering and dive a bit deeper. So I applied for a PhD position at a university in Denmark, where I did my PhD on energy management, specifically on distributed algorithms for energy management problems. So that was research on mathematical optimization and how in a distributed systems with so-called multi-agent systems, you can solve an optimization system and which solves energy or load management problems. And so I did my PhD on that. And then I worked a bit as a postdoc, was doing research for microgrids and multi-agent systems in energy management content. I worked my way up and became associate professor at that university. It's the University of Southern Denmark in Odense on the island Fyn. And in my research since my PhD, which is probably now 8, 9, 10 years ago, I was always working in that field of energy management. At the beginning, it was more like these concepts of having microgrids, so isolated, let's say, islands in the grid, which could live or which could produce enough energy to be independent of the grid. And we were looking into control and strategies and how to implement the energy management solutions. And one thing I was looking into in particular was this how to solve the problem on the basis of multi-agent systems, so that different entities within the grid in this microgrid actually communicate with each other. And they find a consensus how to distribute the energy, when to charge a battery and when to feed, for example, into the grid. And then electric vehicles, they were at that time, let's say 2016, 17, there was still the ongoing discussion, will electric vehicles ever come true, or will it be something else? Will it be hydrogen? But then Tesla came. I think Tesla opened the market for electric vehicles, and it got more serious. And then, of course, our research and our work was also more and more on electric vehicles and all these batteries on the road. And at some point, I was giving talks, and we had developed a system, a distributed system at the university to solve load management problems in a distributed way. So you would have a charging infrastructure, several charging stations, let's say 5 or 10 charging stations, and then we would run some software component on each of these charging stations. And the charging stations, they communicate with each other, and then using some sort of consensus algorithms, they solved the load management problem. And I was going out and I was giving talks about this, and we published papers and so on and so forth. And I got a lot of feedback always that, yeah, this is really usable, and load management and the whole energy management part will be so important in that transition or electrification of mobility. You should make a company. And one day I decided, let's make a company. And the start of the company was that system. And we started it at the end of 2018, beginning of 2019, together with a colleague or with a friend who's more the business part of it. So it's Jan Köster. He had like 20 years experience as a sales and marketing director, which is very complementary to me because I'm really techie. I like technology. I love engineering. I like solving problems. And I thought, okay, I need somebody on the business part for it, because sales, to be honest, I find that a bit boring, or less exciting, I'd say. And we started the company, and the first product we tried to sell was that system. So we built a charge controller for charging stations. So in every charging station, you have the central part in it is a little controller which communicates to the electric vehicle and is allocating charge current to it and make sure that the charging process is established. And we were building this controller, and we were trying to sell that controller to charging station manufacturers.
Okay.
And then with that algorithm on top,
okay,
that's a bit my career in that field.
And that brings us neatly into what FLEXeCHARGE does today. I know you said trying to sell those charge system controllers. So tell us about the evolution of the business over the last couple of years.
Yeah. So, when we started 2018, 2019, well, there were hardly any charging infrastructures out there, maybe some single chargers here and there. And as said, so we were going out and trying to sell this charge controller to charging station manufacturers. So this charge controller with that load management solution on top.
Yeah.
And most of the reactions from charging station manufacturers were either, well, load management, nobody needs that.
Yeah, we don't need it. We're only installing one charge point in each location.
Exactly.
Yeah.
Exactly. And the other comment was, that's nice, but we do it ourselves. Yeah. Or we don't need your charge controller. We already have one. And at some point we then thought, okay, and we could see that most professional charging station manufacturers, if they want to be competitive, it doesn't make sense to buy the charge controller. So the core, the central part of the charging station to buy that from somebody. So they were all developing it themselves. And then we thought, okay, it doesn't go that well with the charge controller. So let's just try with the software. Yeah. So the next approach was then to say, okay, forget the charge controller. We just sell you the software, because we have strong competencies in how to implement and in load management for charging infrastructures. And that went it went better. We found some which were interested. With some we got very close. We even sold it to one charging station manufacturer, but that was nothing which would scale.
Yeah.
And then we sat down again, and we said, okay, what more can we do? And then we came to the conclusion that we should, and by that point, 2 years were gone already. So we are now talking 2020, 2021. We thought, okay, what can we do? And I don't know if you know, but there's a standard communication protocol for charging stations to communicate with the so-called backend system, the charge point management system. And that communication protocol is called OCPP, which is the Open Charge Point Protocol.
Okay.
And that's sort of a pseudo standard nowadays. Nowadays, every charging station supports that standard, and most of the public or commercially used charging infrastructure, they are connected to a CPMS. And the role of the CPMS, so Charge Point Management System, is authorization. So if somebody is using the charging station, plugs in the electric vehicle, then the charging station sends an authorization request to the backend, which in principle is just a server with a database with all the users which are registered to use the charging station, and then the backend will authorize the charging process. But it's also for tracking the charging sessions. So if people have charged at the charging station, that they can be later billed on how much energy they have been used. So we then thought, okay, there is this Open Charge Point Protocol. What can we do to be more open? Because we were so tied to we just had the software, which is really good, well developed, and based on a lot of knowledge from my academic career and also from development through the different steps of the product. And we then decided to implement something we call the OCPP proxy. So that's a proxy. It's a software component which plugs in between the charging infrastructure, so the hardware, the charging stations, and the CPMS. So the charging stations, they are now not connecting directly anymore to the CPMS, to the backend. They're actually connecting to our proxy. And from the proxy, we are forwarding the connection to the CPMS. Okay. So now we have our system in the middle, our proxy, and that proxy we use or still use it because it sees all the traffic from the charging station to the backend and from the backend to the charging stations, and therefore we get the information we need for our load management system, and then we plug the load energy management part next to it. The proxy provides the information. What is the state of the charging station? Somebody wants to charge. It would react on it. And then it can, through the proxy, through that Open Charge Point Protocol, also send standard OCPP, it's called smart charging profiles, to the charging station. So actually we were opening up the system to be used with any OCPP compatible charging station. And that was going like this. Well, nobody will see that, but I'm making an exponential curve now.
Curve. Yeah.
Yeah. So the first thing we did, we put all that software on what we call a gateway, or it's an industrial PC which you would install at the charging infrastructure, and we start selling that. And from that point on, it was completely independent of any charging station manufacturer. It was independent whether the charging station wants to implement our software or not. It was actually sort of an end customer product. Yeah. And I don't know, that was 2021. I remember it was just before Christmas, December 21. And where we had the idea, then we implemented it within 1 year. And then since then, it took off, I would say. We then got funding. We got pre-seed funding from a Danish accelerator program, bit of money. At that point, 2022, beginning of 2022, I was also joining then the company full-time. Until 2022, we had done all that as let's say part-time.
Right.
And
you were still professor at that point?
Yeah, I was still professor, and then we were doing it everything with part-time students, all the thing. But then we convinced these pre-seed accelerator program to invest into FLEXeCHARGE, and at that point Jan and me, we joined it full time, and then we also got a third founder in, which is Max Brandt, to help with further investment and funding of the company, because when you get pre-seed, the next natural step is to get seed funding.
Yeah.
And since then we have developed the product further, and we actually moved away. No, we didn't move away from that gateway IoT or industrial PC solution. The beauty of our software stack is actually that we have it completely encapsulated. So for every infrastructure we operate, and we call an infrastructure, is a group of chargers for which we provide some form of load management, that we have an encapsulated software stack, which we deploy. And we can deploy that on the industrial PC, and then it will be installed with the charging infrastructure. But we can also deploy that on the server cluster, and then we call it cloud-based load management.
Okay.
Which means we then further develop the product into a platform, and that's what we are selling now: a load energy management platform for charge point operators, which they can use as an open vendor-independent platform for load management and energy management to operate their complete portfolio of charging stations. So a big or medium-sized charge point operators, they typically have a portfolio of different charging stations on DC side, maybe 2, 3, 4 suppliers, and then also 2, 3, 4 different suppliers for the AC side. And with that system, with our system, they can actually have a load energy management solution no matter which charging station manufacturer. And they can make hybrid solutions. So we can, if you have 2 DC chargers and 8 AC chargers on a site, we can provide the overall load and energy management for that site.
And that's is that really the value proposition fundamentally for the product?
Yeah, that's a fundamental value proposition. This openness and the option to have it local or to have it in the cloud, and both are combined in. So there's a whole backend now. We developed a whole backend behind it and a nice user interface, which occurs as one homogeneous platform for all the infrastructures. And then it doesn't matter if our software stack is running on that industrial PC or if the software stack is running in the server. It is all connected in our platform. And what we can even do with our platform is we can combine all the infrastructures, no matter if a gateway or a cloud-based stack, into virtual power plants. So we can operate and we can group them into big virtual power plants, and then connect them with an external system to drive all the infrastructure down, to drive them up, follow pricing signals, follow the electricity market, the
wholesale
market
yeah.
signals. Yeah, exactly.
So is that more like the next bit, or in terms of using vehicle to grid, or is that you're actually doing that now in terms of load management? And
no, I'm talking about load management the whole time because, from my academic background, we were talking about vehicle to grid and grid services like 10 years ago already. But of course, the market is a bit behind.
Yeah.
And right now, and that's the reason. When we originally started with FLEXeCHARGE, we were also talking about scheduling. So how you could schedule the charging of an electric vehicle to follow local availability of energy resources, for example, to charge the electric vehicle based on availability of power from photovoltaics, or follow a dynamic price prediction for the next 12 hours or something. But 2018, nobody was ready for it. We had, at that time, as I said, we had to explain them what load management is. What is the difference between static and dynamic load management?
Yeah.
And only now, we are seeing that all these visionary ideas and all these things for which we started FLEXeCHARGE come actually true. We see we see weakness, and we see the customers asking for grid services, for example, frequency response.
Yeah.
So you can provide frequency curtailment reserve with your charging infrastructure and things like that. That would have been 2018. I mean, that
Yeah.
people will say, okay, come on, what you're talking about. And there have been so many things. And at that point, I mean, that's why we, at the beginning, it was really for the company to survive and to have some sort of product market fit. And the product which the market needed at some point was just simple load management. I know it doesn't sound exciting, and probably it is not. It is exciting. Many people say, well, that's so easy. You just divide, if you have 100 available, you divide it by 20. If you have 5 EVs charging, you divide by 5, you get 20 per vehicle. But that's not what it is. There's much more behind it. That's in principle, it sounds easy, but the tricky thing is all the corner cases. What if the charging station is not responding? What if the charge current is lower than you allocated, and so on and so forth? That's the intellectual properties. Yeah.
I think it makes sense with if you have a vehicle on charge, particularly with the fast rapid, it's not necessarily taking full power all the time. In fact, it is very rarely taking full power. And
exactly.
I'm imagining you probably prioritize as well, because if someone turns up with an empty car, you want to give them a bit more than someone who's trying to get it from 70 to 80%, for example. So there's kind of prioritization and dynamic management based on what the state of charge in the different cars is, and then therefore what the charger demand. It's interesting that in the early days it was quite unusual to get more than one rapid charger in one place, and now actually it's becoming more and more common to have a mix of different powers of rapids and also some AC low power destination chargers and things like that. So it's kind of these mixed charging parks are becoming much more a thing. And even if it's not, people might not necessarily see it as a mixed charging park, because it could be something like a supermarket car park, and in one corner they have some rapids, and in another corner they have some 7 kilowatt ACs. But actually, on that site, they're all connected to the same grid connection.
Exactly. And usually what you also see, at least for this destination charging sites, that you have a building next to it. So you have charging infrastructure, you have the charging infrastructure, hybrid, maybe 2 high power chargers, and then a number of AC chargers, as you said, but then you have a building. And that is what we call dynamic load management. In that case, our system is actually measuring what is the building consumption in real time, with a high frequency, and then it's adapting the charge currents for the infrastructure with respect to what is the consumption of the building, so that the maximum limit at the grid connection point is not exceeded. And that's then, after talking about static load management, that was if you look into our product, it was actually the next step. First, it was static load management. Then it was what you said, adaptive static load management, where our system actually is detecting if I allocate 20, let's say kilowatt, and it only charges with 15, that it allocates to that, and that it adapts to that, and is only charging is allocating only 15, so that others can charge more, to maximize user experience. And then the next step was building consumption. Then we probably that came together is a PV-based charging, so that you can, if you have a PV system on the top of the roof, to adapt the charge current. So if there's an overproduction from the PV panel, so they start feeding into the grid, that the charge currents are increased, so they would take the energy from the PV panel. One thing I have to say, which I probably didn't mention yet, is that we have a specific customer segment. Did I say that? It's a CPO. So we are really focused on charge point operators, big, medium-sized charge point operators, which operate charging infrastructures of size. So the smallest one are maybe 5-6 chargers, and the biggest ones we have over 100 chargers connected. Yeah, so we are really focusing on that segment, which is also one of the clear differentiators to our competitors. So it's nothing for home residential use.
Yeah.
The whole pricing model, the whole technology stack is actually made for that. So it's these charge point operators, and the other segment, we call it the charging solution providers. This is companies, they technically operate the charging infrastructure. So they provide that as a service to build this charging infrastructure and then to technically operate it and maintain it, but they are not selling energy to the charging infrastructure, which a typical charge point operator is doing. Yeah, so charging up on the motorway, CPO, 8 Alpitronic high power chargers, for example. The main goal is to sell energy.
Yeah. And with the other type, the technical, what do you call it? Technical operator, would that be more like, let's say if you're, I don't know, a logistics company and you're running an electric fleet, they're kind of in-house.
No, exactly.
So you're not selling power, but you're running it, your own vehicles.
Exactly.
Okay.
Yeah. If you have a big, let's say DHL or something, they have hundreds of logistic centers, and for each of these logistic center, they have a charging infrastructure. Then they probably have in-house team to operate that charging infrastructure, and that is something like a CSP. But there's also dedicated companies now, and there's probably every week there's a new one which provides that. So if you have a company or you have your retail market operator or whatever owner, and you need charging infrastructure, then you go to these companies, engineering office, something, and say, okay, I need 15 charging infrastructures at this and this locations. Can you please set them up for me? And can you please also operate them for me? But the energy I buy from the local energy supplier. Yeah. For the charging.
So they're supporting the asset, and if the charger breaks down, they're fixing it, but they're not responsible for the sale of the electricity.
Yeah. Talking a bit more about the technology, I mean, one thing which is also really important, or where we have built up quite a lot of intellectual property, I would say, is, of course, with our architecture. What I said, I often call it a 3-layer architecture. So you have the charging infrastructure, so the hardware, the chargers. You have this backend charge point management system, and then, as I said, we are plugging in between, with our OCPP proxy, that we put a lot of focus on that proxy, because we know it's a first point of connection for the charging stations, and therefore it's crucial that it has the uptime, the redundancy, and everything built in for the CPO to operate the charging infrastructure stable. So starting off in 2018-19 with this distributed algorithms idea, or distributed load management idea, that proxy part has also become a crucial, important part of our product.
And is that, I'm just kind of imagining, is that because of the local infrastructure you'd put in, which then gives the site some resilience if it loses its internet connection, for example, the charge points can continue?
Exactly. That is one reason why customers often ask for that gateway, we call it, that industrial PC with our software on top. But we have also the whole, now talking about the cloud architecture, or the server cluster, which runs these software stacks. We have built in resilience there. We have a whole system behind which monitors the state of these stacks, and if a stack goes down, it's automatically restarting it. Is spread over a number of servers. If a server goes down, the system will recognize it and and spin up the stacks on another server and so on and so forth. So there's a lot of, because the uptime, that's some of the questions we get from big CPOs, because that's important for them.
It's become an increasingly visible problem in the industry, with a lack of the right word is reliability or availability of charge points. That's the sort of see this sort of same message repeated again and again. It's not range anxiety, it's now charger availability anxiety.
Exactly.
When I get to the charge point, will it actually work? Because quite a few of the networks are probably ones that were developed before the technology was mature, and there's not getting maintained properly and things. So I can imagine you want to you want your product to be available, basically.
Yeah, it is one of the crucial things for CPOs, and the differentiators, and it's so important.
And is it your kind of application is the proxy? So you're taking all that standardized information in. If you're looking at a building, you must also, are you putting sort of hardware in place to look at the building, or so you've got some building monitoring system. What about the one kind of use case that we haven't talked about? You mentioned solar, but I see becoming increasingly common is for people to be putting local battery storage in place, particularly if they've got solar. And is that something you're seeing as a requirement?
Yes, and you hit the nail on the head. That we also saw that, and we saw the trend upcoming in the next last year. So you could see already in the last year, you could see CPOs more and more talking, or it got more interesting for them to install a local battery rather than asking for reinforcement of the grid connection. Yeah, so there's a transformer substation, maybe with 2 megawatt capacity, and you put a charging infrastructure behind it, and then charging infrastructure gets utilized, and if the utilization gets too high, and you want to add more chargers, there's only two ways. Either you put you in a reinforcement of the transformer substation, so more power, and power gets more and more difficult. And then the other option is put a battery. And we have seen that, and actually we have started now. And this year, this quarter, we integrated the first battery into our system, so we can operate that next to the charging infrastructures.
Okay. I can imagine, so from a personal perspective, I have at home, we have 2 charge points in our domestic setup, so it's a bit unusual. But probably not that surprising to people listening, bearing in mind what I do for a living. But we also have solar installation, and we have a domestic battery installation. And just with a domestic setup, the one thing that is a constant kind of issue for me is tailoring the amount of energy that I put into the storage battery using the low price electricity versus the solar input versus the charging demand, because it changes a lot. Like in the winter or on a day where you're not going to get much sun, you need to kind of know what the weather's going to be like tomorrow, plus your charging demand, to then go, actually, I need to charge that stationary battery up to a particular level tonight to get the best value. And there's that is all of a sudden, I mean, I'm trying to work that out in my head all the time, and it's quite complex. But if you're a CPO, you're not going to be doing that. You need some software and some algorithms that can do that kind of thing. That starts,
exactly.
And this is, are you building that kind of functionality into the system, or?
Exactly. Yeah. I mean, and now that's where the excitement starts, and that's also what customers are asking now. So for us, that's a big roadmap topic for this year, and actually integrating the battery is the first point in it. And then the next point, what we are offering to charge point operators, because with our system, the beauty is that we are gathering a lot of information about the charging infrastructure, and we are measuring, or we are receiving the charge current. So we set up the charging infrastructure so we receive the charge currents at a really high rate every 15 seconds. So we get a whole load profile over the operational time of the charging infrastructure, and we can do really detailed analytics of what the demand is. And we can tell the CPO if he wants to buy energy at
cheap
trading.
Rates.
Yeah, exactly. He gets a projection for the next 24, 48 hours, what his complete portfolio of charging infrastructure need is. Yeah. And so this energy trading is one part of it. And the other part, as you rightly said, is how to integrate the battery into it. Yeah. So how much energy you actually need in the battery to overcome times of high utilization. So, for example, you have peak loads in your charging infrastructure, let's say at noon every day, where the system usually would scale down the charge currents, and you can get less through, and then the battery kicks in. Yeah. And then our system can exactly tell what is needed by the battery. So how much does the battery needs to be recharged overnight? We can even couple that to a tariff, to a dynamic tariff, and charge the battery cheap overnight. And of course also tell the CPO how much energy he should buy. And then we're coming to also a very important roadmap topic in this year, where we start now working with 1-2 customers in Denmark and also in Norway, together with a battery manufacturer, which we now have integrated, is all these frequency curtailment reserve, so demand response. So where your system, your charging infrastructure, with the charging infrastructure, you provide frequency response. And that requires that you have really, really detailed information about what is the load and what you can provide in the next day, because there is a market for it where you have to place bids. So you can place a bid to say, tomorrow between 12 and 1, I can provide 0.5 megawatt. You compensate frequency variations, to stabilize the grid. You can place a bid, and there's a whole market integration to that to place the bids. And if you win the bid, let's say tomorrow between 12 and 1, and you get the signal to drive down your infrastructure, you better make sure you deliver. Otherwise, you pay. You pay. And for that, you need a whole system for automatic data analysis, for automated decision making, for placing these bids, risk analytics or analysis. So what is the risk that you cannot deliver? And that is something we are currently setting up for a customer as a pilot in Denmark and Sweden. And the story about the PV, which you used as an entrance, is interesting. But I have to say, for CPOs, it's not that relevant.
Okay.
At least now for CSPs, what I said, these charging solution providers, it is interesting. Yeah.
And is that because the CPO doesn't have enough real estate to put panels on to give a significant input, basically?
Yeah, first of all that, and secondly, it's a hot, how you say, it's a drop on the hot stone. It's like, you should imagine you're having 8-10 hyperchargers, each 300 kilowatt. What solar system you need on top or next to the infrastructure to then charge? And for CPO and for public infrastructure, the objective is to deliver energy and provide maximum user experience, and then you don't want to reschedule some charging processes. It is interesting if you have a local battery. Yes, for sure. For CSPs, for, as you said, logistics center, and we had last year we had done some pilots towards that, and there are tools available to predict. I mean that's what all the solar installers or how to say when you plan a solar system, they do usually these. They have all the tools to project based on the weather forecast what is the estimated solar production on the next day. If you want to charge electric vehicles on the basis of a solar system, there are some more challenges in there, which is the information. It's a bit tricky right now to get the information from the electric vehicle, what the demand is. So if electric vehicle arrives to a charging station, well, and you want to schedule the charging, let's say they arrive at 8 o'clock in the evening, the vehicle stands there all night, and you say, okay, let's charge the electric vehicle based on a schedule, which is easily possible, or based on a dynamic tariff, on the pricing signal. You need to know the information about what is the demand, how much kilowatt hours does the car need, and what is the departure time. And that means you need some interaction with the electric vehicle. Right now, you wouldn't imagine how old school the communication protocol between a charging station for AC chargers, between a charging station and the electric vehicle is. It's based on some sort of analog signal, pulse width modulation, but it's not possible for the charging station to get the information out of the electric vehicle, what it actually needs. You can just say, okay, you charge now, or you charge with this charge current, or you stop charging. So you need a whole integration with the user, or using communication directly with the electric vehicle to get that information out to plan a schedule for charging for the vehicle. So there are some challenges involved. And then if you think about the public infrastructure, that gets even more difficult. But there are some ideas there.
You're not going to have access typically to that sort of data. I wonder, just kind of going back to your base case business, because it is often a thing people talk about. Obviously, the more EVs that are deployed, grid connections become more of a problem. But we do have this sort of odd, the design principles typically, historically, for grid connections and buildings and things, tended to always be based on like a worst case demand scenario. So there's a lot of buildings that exist that have effectively very big grid connections that don't actually utilize fully, or even if they do utilize it fully, it's certainly not, not the whole time. What do you, if you had to kind of estimate by having a smart load system, smart load management system like you have developed, what's the saving in terms of the grid connection? Is it making that most of the time they don't need an extra grid connection or that reinforcement you mentioned, or can you kind of equate it to a power level saving?
That's hard to tell, a power level saving, but I think mostly it is to prevent reinforcement of the grid connection point. I mean, even if you have high utilization of the building during periods of the day, it doesn't mean that you can't have, or it does not mean that you can't have a charging infrastructure. You still can have the charging infrastructure, but then it can just not charge at that high utilization times. And I think the equation is more, you try to fill the tube, so to get the maximum out of your grid connection point by utilizing it as much as possible. And that's not only true for a building. That's coming back to the CPOs now. The goal is to have 100% utilization 24/7. Then you get the maximum out of it. And I can't give you any numbers because that's so different and it's so specific based on what we're talking about.
And that, I guess, so with a new installation like a CPO, they're paying for that grid connection, and they have to pay to build the grid connection, but then they also have to pay based on the size of the grid connection, the kind of an ongoing charge. So when you're designing a charger park, you want to minimize the installed cost and then the maintenance cost for the grid connection.
Yeah, and the point is the infrastructures which are set up these days, they are all oversized. They are all, I mean, they are very often not perfectly utilized. So they are not making money right now. They are an investment into 5 years for higher utilization. And in some European countries, when the CPO is actually making a contract with the grid operator for specific maximum limit they should not exceed, during the whole year. And if, however, they exceed that limit, they will pay like crazy fees of like €100 per kilowatt, for example. And we have customers, they are using our system to prevent these peaks, because a peak, if it occurs only once a year, the CPO will pay for it. And they easily pay 30,000, 40,000 euro for that.
Wow.
And then they use our system, even though they have a 2 megawatt grid connection possible, we limit the infrastructure to only 500 kilowatt because the 95% of the load on the infrastructure is only that. There's only a few, 2, 3, 4, or 10 times a year where they need higher power, and they don't want to pay for that. They want to make the contract for 500 and then just prevent these peaks. And that's what they use our system for. And the nice thing what we do for them is also to tell them how often is the load management active. So how often does the system go into the maximum limit, so that charge current needs to be reduced. And then you can see, of course, if that gets more and more frequent and happens more and more often, that slowly you need to increase the maximum limit, to of course, what they want to do is sell energy.
Yeah, it's interesting. It's a trade-off there of
exactly,
because of the way they pay for those grid connections. You don't want to be overpaying. Yeah, interesting. So just a couple more questions. It's been really, really fascinating, and I think we could we could
for hours.
Yeah, we could go all day on this. But just to give people an idea, you said that it's sort of taken off in terms of the business. What FLEXeCHARGE as a company, what do you look like at the moment? How many CPOs are you working with, etc.? What's the kind of scale of the business?
Yeah. So, I think we didn't finish the whole story about FLEXeCHARGE or the general company story yet, because there has been some excitement in December. Just I think it was a week before Christmas. We got a seed investment, rather big one, from 3 venture capital companies, VCs. And that was really exciting because that was against the market trend. End of last year, or whole last year, it was really difficult to get venture capital money. So we were really excited that we got it. It was also great. It showed us that we are on the right track with the product, with the overall idea, with the team also. So we got that investment, and now the company is scaling. So we have only in the last 3 months, on Friday, we had 3 people starting on just one day, 1st of March. And before that, we also have employed 3-4 people. So we are scaling, which is good. And we also now have the financial backing to go a bit more into what we wanted to do, like visionary and innovative things, like everything I told you about this analytics, grid services, frequency curtailment reserve. We can invest into that, and what we want is we want to become the forerunner in load energy management for CPO. So again, CPO is the keyword here, to provide them to make their charging infrastructures profitable, and provide grid service and give them all the tools for load energy management to operate it in the best possible way economically. And so that's now what we have on our roadmap. And in terms of customers, as I said, when I said it kicked off in 21, 22, something like that, with that solution I described, we got like little CSPs, companies here and there which set up charging infrastructures. But since then, the customers have become bigger and bigger, probably also because as a result of the product was getting better, we got known in the market. We sort of built up trust in our solution, and we are now running with like 15, 20 customers, which we have so far. But it's getting, as I said, the quality or the size of the customers is getting bigger and bigger. I can't name any. I would love because there are some really exciting names in it. If you know the e-mobility community or CPO community, you would know them. But unfortunately, I can't. Maybe we have another talk in the year, and then I can name if they have become our customers. But it's getting bigger. So we are looking now. We had we call them local heroes. So we had CPOs. Which maybe had, or we have them, which have 20, 30, 40 infrastructures, like local gas station operators, which have some gas stations, and then they build up charging infrastructures. So I call them local heroes, but now we are talking to national heroes, so players which build up charging infrastructure for complete countries.
Interesting. So just a last question to close out today's episode. What are you excited about that's going to be happening in the future for the business?
For the business, well, once again, I get really excited by technology. So I'm excited about all these things which we are working on right now. What I told about, but I think it will really kick off now in this year. We will get some bigger CPOs, national players, and then the next big goal is to get, we call them enterprise CPOs, and then we are talking, I don't want to name them, but that these are international CPOs. I mean, that's the goal for the company, to get 1, 2, 3, a few of those. And so that's the goal for the next, I would say, 2 years. To become really the leading provider platform, load energy management platform provider for CPOs in Europe. And then I think in the sort of midterm 2-3 years perspective, we are also looking into going across the Atlantic. Already now we are getting requests from all over the world. We get a lot from North America, but we think it's too early, for the company to enter North American market. But it's certainly interesting, and it's going to be the next step. But we also get requests from Australia, from all over the place, which we decline these days because it's a bit tricky with support to try to focus on Europe now, this year, next year, and that will be exciting. That will be so exciting to see FLEXeCHARGE, for example, in North America. That's so nice. So that's what we're working towards.
Fantastic. Well, it's been brilliant to talk to you today. I've learned a lot as I have done on some of these podcasts, but that's been really, really interesting, and I'm sure that the listeners will have got an awful lot out of that as well. So for people listening, if you want to find out more about Robert or FLEXeCHARGE, if you go down to the show notes below, you'll find some links to them. and some other things that we've talked about in this episode. Don't forget, obviously, if you've enjoyed this and you're not subscribed already, make sure you do subscribe, because we are putting out episodes fairly regularly. So make sure you don't miss any. We're still putting the episodes onto YouTube as well, which some people do like. So you can go over there if you want. You don't get to see anything. We don't record the video for these, so it's audio only. But there is YouTube there, as well as all of your other favorite podcast platforms. So thanks for taking the time to talk to us today, Robert, and thank you to all the listeners for taking the time to listen to this episode. And we hope to talk to you again soon.
Yes, thank you. Thanks a lot.